Good morning. Today, what we're going to do is look at 1.3 in college math, which is about fractions. We're going to start by talking about prime and composite numbers. To start with, prime numbers, any number whose factors are 1 in itself. We're going to start by finding all of the numbers between 1 and 100 that are prime. To do this, we're going to use the sieve of Aristophanes. If you could pull that out, it was given to you in class. Now, following the directions on this, it says we cross off 1 because 1 is not prime. So, cross that off. The first prime number is actually 2, so we circle that. When we finish, we're going to have all the prime numbers circled. Now, anything that is a multiple of 2 will not be prime. So what we're going to do is cross off everything that is even. So anything that ends in 2, 4, 6, 8, 10, or in this case 0. Okay, crossing all those off. Next up, we say circle 3 because 3 is the next prime number. Now, everything that is a multiple of 3 is going to be crossed off. There's a pattern for this as well. So, everything that is a multiple of 3 is going to cross off. So, then coming down this way, all of these numbers, a little jaggedy there, that's alright. Alright, so there we go, getting all those done. Alright, next up we circle 5. 5 is our next prime number. So then we cross off all the multiples of 5. So that would be anything that ends in a 5 or a 0. So those are already canceled for you. The last step then is to circle 7. And then what I'd like to do is go through and cross off any multiples of 7. There is no pattern for this one, so if you'd like to pause the video and try this yourself, then everything that's left will be a prime number. So I'm going to just go through and circle my primes and cross off anything that's a multiple of 7. It is crossed off already. And 97 is our, last prime. There we go. So this list you might want to keep handy because it's going to help you in the next set, which is looking at composite numbers. Composite numbers are any whole number that can be written as a product of primes. Some of you might remember this from way back in the day when you used to do the factor trees. Yes, that's what we're going to look at here. So what I'd like for you to do is think, okay, what are some different numbers that would multiply to give me 40? There's lots of different ways to do this. I'm just going to go with 2 times 20. Now 2 is already prime, so we don't need to worry about that, but 20 is not, so we are going to break that down. Now we could use 4 times 5. Now 4 is not prime, so it needs to be broken down further into 2 times 2. 5 is already prime, so we leave it. Go back and look. We have 1, 2, 3 2's, so 2 to the third, and a 5. This 2 cubed times 5 is the product of primes. So what I'd like for you to do is to please pause the video and try to write 63 as a product of primes. Okay, your final answer should have been, looks something like this. So 7 times 9. 7 is prime, so I don't break that down. 9 is 3 times 3. So we end up with an answer of 3 squared times 7. Now, if you'd like to, you could write 7 times 3 squared, but the proper grammatical is to write in order from smallest to largest. So 3 squared times 7 would be more correct. Next up, we are going to look at writing fractions in lowest terms. This uses what we call the fundamental principle of fractions. And you've seen this, it's just giving it a name now. If you have A times C over B times C, it's equal to A over B because C over C equals 1. These C's can cancel each other out. So looking down here, some examples for you. What we're going to do is use 42 as a composite number, so we can split it up, and 49 is also composite. So what I'm going to do is split 42 into 6 times 7 and 49 into 7 times 7, because now it pops out at you that the 7's will cancel and you'll have 6 over 7. Now 6 is still composite, 2 times 3, but none of those combinations are going to cancel with our prime number of 7, so your final answer is 6 over 7. 11 over 27. 11 is prime. There is no factor of 11 and 27, so this is in its most simple form. Nothing will cancel. I'd like for you to pause the video and try the next one. Okay. First thing I notice is that 88 is even. 2 times 44. And 20 is also even. 2 times 10. Right away I notice that 44 and 10 are both even again. So what I'm going to do is rewrite 44 as 2 times 22 and 10 as 2 times 5. Now what I see is that my 2's cancel from the first time and my new 2's cancel, leaving us with 22 over 5. Now check. 22 is 2 times 11. 5 is prime. Nothing else will cancel. Final answer, 22 over 5. Some of you are wondering why we don't change this to a mixed number, 4 and 2/5. The reason that we're not going to do that is the first thing that you do with a mixed number is change it into an improper fraction. Improper fraction is where the numerator is larger than the denominator. So we're just going to leave it. For all intents and purposes in this class, what I'd like for you to do is if you have a fraction, leave it reduced and as an improper fraction. All right. Last thing that we are going to look at here, oh no, it's not the last thing, sorry. Looking next, we have what are called equivalent fractions. Equivalent fractions are fractions that represent the same quantity. This is the opposite of reducing a fraction. So what we're going to do is we're going to take 2/5 and we're going to rewrite it so it has a denominator of 20. Well, what would you have to multiply 5 by in order to get to 20? You would have to multiply it by 4. Now, if I multiply by 4 over 4, I'm multiplying by 1, the value of 1. So I'm not changing the value of my fraction, I'm only changing its look. So that's going to give me 8 over 20. Okay, this is just writing equivalent fractions. Next up, we are going to look at multiplying and dividing fractions. To multiply fractions, you simply multiply straight across the top and straight across the bottom. So, an example for you. 2/15 times 5/13. We can first of all multiply straight across the top and get 10. And then second of all, multiply straight across the bottom and get whatever 15 times 13 is. Now, I don't want to go digging around for a calculator, so what I'm going to do is show you a bit of a shortcut so that you can look super smart and do this all in your head. All right, so 2 times 5. 2 is prime and 5 is prime, so we can't do anything with those. But look at this 15 right here. Can we rewrite that as primes? Yes, we can. We can rewrite 15 as 5 times 3, and then the 13 is already a prime. Does anybody notice what can happen now? Yes, that's right. The 5's will cancel, leaving you with a 2 over 3 times 13, which is 39. So a little bit easier to multiply that in your head than 15 times 13. Okay, it's reduced. We don't have anything left to do, and that's what multiplying fractions. Dividing fractions is just multiplication in disguise. Think about it. Multiplication and division undo each other. So to divide fractions, what we do is we change from a division sign to multiplication by the reciprocal. Okay, and it's always the reciprocal of the second fraction. Okay, just a little quick reminder here. This is a word that you will see on your vocabulary test. C over D and D over C are reciprocals because the product is 1. Make sure you write this down somewhere. All right, so let's check this out. So, rewriting 4/5 divided by 5/16 into 4/5 times 16/5. Now, does anything reduce for us on this one? It does not appear that anything will. So we're going to go ahead and have to multiply those. You might need to dig a calculator out, and we're going to get 64 over 25. All right, the next one, 7/10 divided by 14 becomes 7/10 times 1 over 14. Keep in mind this is 14 over 1 if you need it. Now, does anything cancel here? 7 and 14 is 2 times 7, so those 7's will cancel. Nothing else will, leaving us with 1/20. Okay. Last one here for you to try. Go ahead and pause the video, try this, and come back when you're done. 3/8 times 10/3. So what I'm going to do is rewrite 10 as 2 times 5 and 8 as 2 times 4. Do a little cancellation, the 3's, the 2's, leaving me with 5/4. Have a good day.